to explore intermolecular and intramolecular bonding. So our learning intentions are to describe the differences between intra and intermolecular bonding and discuss van der Waals forces, dipole forces and hydrogen bonding. So what we've looked at in our previous videos is we've looked at types of bonds that occur inside and within a molecule, and these are called intramolecular bonds. So intramolecular bonding is bonding that takes place within a molecule. So examples of this include covalent and ionic bonds, as they hold the atoms inside the molecule together. So that's why you'll see here in the video that I have highlighted the A for intra and A for atom. So in this video, we're going to look in greater detail at the intermolecular bonding that occurs within molecules. And intermolecular bonding involves forces of attraction that exist between molecules themselves. So we'll be looking at different molecules and how they interact with each other. There's three types of intermolecular forces that we're going to look at that occur between molecules, and they are van der Waals forces, dipole-dipole forces, and hydrogen bonding. So with each of these, we're going to look at what they do and how they affect the boiling point of certain molecules. So the first group that we'll start with is van der Waals forces. And van der Waals forces are weak attractive forces that occur between molecules, resulting in the formation of temporary dipoles. So they are the only forces of attraction between non-polar molecules such as nitrogen and hydrogen. Now we know that these dipoles are temporary because the small attractive forces of van der Waals forces just cause a temporary internal shift of the distribution of electrons within a molecule. It's not a permanent shift. And this is because electrons are moving at such a high speed. So we know that hydrogen has a boiling point of minus 250 degrees, but oxygen has a boiling point of minus 183 degrees. So we want to be able to account for this difference in boiling point. And the higher boiling point is due to the oxygen van der Waals forces being stronger than the ones in hydrogen. And this occurs because oxygen has a bigger atom than hydrogen, meaning that it contains more electrons than hydrogen, so there is more temporary dipoles formed. So that means that more heat is needed, or energy, to break these forces, so that gives us a higher boiling point. And this example is quite a common explanation that is required in exam questions on intermolecular forces. The second type of intermolecular force we're going to look at is dipole-dipole forces, and dipole-dipole forces are forces of attraction between the negative pole of one polar molecule and the positive pole of another polar molecule. So dipole-dipole forces are only present in polar molecules. So compounds that contain molecules with polar covalent bonds will have these permanent dipole-dipole forces. Now, dipole-dipole forces are caused by a partially negative end of one molecule attracting itself to the partially positive end of a neighbouring molecule. So as we can see here in this slide with the hydrogen chloride, we can see that a dipole is created within the molecule. So the hydrogen has a slightly positive charge, but the chlorine has a slightly negative charge. And it's this slightly negative charge that attracts itself to the slightly positive charge of another hydrogen molecule. And we can see here that the slightly positive charge of this hydrogen molecule is attracted to the slightly negative charge of this chlorine here. So since most of the electric charges are partial, this makes the dipole-dipole forces weaker than ionic bonds, but they are stronger than van der Waals forces. Dipole-dipole forces will give rise to higher boiling points than those of similar non-polar molecules. So, if we look at a comparison between methanol and ethene, we can see that the methanol has a much higher boiling point than that of ethene. And this is because dipole-dipole forces exist between methanol molecules, but only weak van der Waals forces exist between ethene molecules. And this is because the ethene molecules are nonpolar. The last intermolecular force we'll look at is hydrogen bonding, and hydrogen bonds are particular types of dipole-dipole interactions between molecules in which hydrogen atoms are bonded to nitrogen, oxygen, or fluorines. Now, hydrogen atoms carry a partial positive charge and are attracted to the electronegative atoms of the other molecules. So, for example, the nitrogen, the oxygen, or the fluorine that's present in the other molecule. So, the hydrogen bonds act as a bridge between two electronegative atoms in a separate molecule. And this bridge is usually shown by dotted bond. So, molecules that undergo hydrogen bonding will have a much higher boiling point because a considerable amount of energy is needed to break hydrogen bonds. So, for example, hydrogen sulfide and water have similar structures, but hydrogen sulfide has a boiling point of minus 60 degrees, but water has a boiling point of 100 degrees. So water has a higher boiling point due to the presence of the strong intermolecular hydrogen bonding that is present between the water molecules, as opposed to the weak van der Waals forces that are present between the hydrogen sulfide molecules. So the last thing we're going to look at is dissolving covalent compounds in water. And we know that only like will dissolve like, meaning that polar compounds will only dissolve in polar liquids, and non-polar compounds will only dissolve in non-polar liquids. Now, we know that ammonia has a high solubility in water, so we need to be able to explain this. Firstly, ammonia is a polar molecule and water is a polar solvent, so like will dissolve like there. But why does this happen? So it's due to the formation of hydrogen bonds. And hydrogen bonds form between the slightly negative nitrogen atoms of the ammonia and the slightly positive hydrogen atoms of the water. So as we can see here, the slightly negative nitrogen forms a weak hydrogen bond with the slightly positive hydrogen of the water. And similarly, hydrogen bonds form between the slightly positive hydrogen atoms of the ammonia and the slightly negative oxygens of the water. So as we can see here, the slightly positive hydrogen of the ammonia forms a hydrogen bond with the slightly negative oxygen in the water. And these hydrogen bonds is what allows the ammonia to dissolve in the water. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.